Hi everyone, a very good afternoon to every one of you. Good afternoon friends. Welcome back to PW NEET English and class 12th formula revision. As you guys know, we have already completed class 11th formulas. Along with formulas in this live class, we are going to also talk about all the important notes and some of important questions as well, right? So this is just not about formula revision. We are going to talk about graphs. We are going to talk about important statements. We are going to talk about statements from NCERT. So this lecture is going to cover all of those things. It's going to be very important for those students who want to revise physics in these last few days, right, very efficiently. So please remember, formula is revision for those students who have completed their substantial amount of syllabus and then they just want to revise it once again, maybe before their mock exam, or now you don't have to give lots of mock exam because we have got just like 7 days left for NEET 2026 exam. So I think it's a good idea to revise through formula revision twice a day, at least once a day. Through these formula revision, we can actually have a look on all of those topics, all of those formulas which are not considered important, right? Yes, we are completing whole chapter, right? We are completing whole chapter. If you are going to see the previous lectures of class 11th also, I think we have completed more than it is needed. So this is very important. Right. We are going to complete it, Arya, and as promised, I'm going to compile all of these PDF into one single PDF, and I'll try my best that I can get this PDF to you by today evening. All right. So without any delay, let's start, because at 3 p.m. you have got your biology class by Ambika ma'am. So let's quickly start. First of all, we are going to go with the order. We are going to talk about electric charges and fields. There are, see, I'm talking about each and everything, even about the charge, right? So these things are really easy. So for all the easy topics, we are going to just have a glance on this. For example, as elementary value of elementary charge, additivity of charge means charge is a scalar quantity. You can add them, you can subtract them. It is quantized, right? Please remember the properties of the charge and do not spend more than 5 seconds on these things, right? This is very simple, correct? So then you have got a very important thing, which is distribution or redistribution of charge. I mean, NTA has asked some problems from this particular topic in few last years. So please remember, in this distribution of charge, these bodies, these spherical objects have identical shape, identical size, right? So radius is same. That's why the final charge becomes the arithmetic mean of the initial charges. So q dash is equals to q1 plus q2. Remember it. The basic concept lies in common potential. Right now we are not talking about common potential because radius is same, so we know that charges will become equal, right? Then you have got charge densities. Please remember this thing also. This is very easy. Linear charge density, surface charge density, and volume charge density. So this is very easy. Moving on to the next one. If you have any doubt, do let me know. Just like the last class. If you are going to ask me anything, I am going to explain it to you, right? That is why we are having live classes. Very good afternoon. Be quick. Yes, right. So now let's quickly move on. We have got Coulomb's law. Coulomb's law is very important as far as permittivity is concerned. Please remember its dimensional formula. I have already told you this in units of dimension chapter also. Other than this, if instead of air, we have got some another medium having dielectric constant K. So we all know that the force in that medium becomes 1 upon K times, right? So this is also very easy. My dear friends, there is one thing that I want you to know, and that is, okay, just a second, and that is Coulomb's law in vector form. Again, NTA has asked, my dear friends, NTA, just a second, let me, yeah. So, my dear friends, NTA has asked a question from Coulomb's law in vector form, right? So please remember this law in vector form also. For example, as I'll be a little quick. Let's suppose that you have got two charges and they have position vectors something like this. Let's suppose R1 is position vector for a charge Q1 and R2 is the position vector for charge Q2. Right? Now please try to remember it just like I am explaining it to you. Let's suppose we want to calculate the force on Q2 due to Q1. So let's suppose we want to write down force on 2 due to Q1. So you are going to write it something like this. Force on 2 due to 1 will be K Q1 Q2 upon multiplied by R12 cap. R12 cap and divided by R12 square. That means mod of R12 square. Now please try to understand this, because again let me tell you, they have asked a question from here. This is R12, my dear friends. R12 basically means R2 minus R1, right? Don't get confused with how I am writing it. If you have somewhere seen it written as R21, that is also correct. Main point is that we have to write it as R2 minus R1. They can ask a question from here, and please remember, then we can rewrite this thing as K Q1 Q2 dot R, my dear friends, R2 minus R1, right? This is vector divided by mod of R2 minus R1 and cube of it. This is very important. Right? Got it? So please remember how we write Coulomb's law in vector form. That is going to help you. Okay, yeah, I think that's more than enough. Alright, now let's come back to equilibrium of charges. Alright, let's come back to equilibrium of charges. Now again, this is a particular topic where you can save a lot of time using short tricks, and I would suggest you to use short tricks in this. Equilibrium points means a point where net force because of both the charges will be zero. For example, as let's suppose that this charge is at equilibrium, this charge is at equilibrium. Got it? Please remember, equilibrium, whenever they say equilibrium, if they are saying system is in equilibrium, that means all the charges which are inside of that system are in equilibrium. That means net force on all the charges will be zero. If they are saying only this charge is in equilibrium, that means net force on small q is zero. Got it? So if net force on small q is zero, and by the way, if this small q happens to be in between of these two charges, that means that these are like charges. These are like charges, right? And then you can directly use this formula, that is Q1 upon Q2 is equals to R1 upon R2 whole square. Another formula is, my dear friends, R1 plus R2 is equals to R. So you have got two equations and you have got two unknowns. You can easily find out R1 plus R2 is the total distances, let's suppose R. So usually they give you total distance, they give you Q1 and Q2. That means Q1, Q2 is given, R1 plus R2 is equals to R is given, so you can find out R1 and R2, right? Hopefully everything is clear. Now please see how many important things I have written over here for you. Again, please remember, simple pendulum is going to be very important for you. Wherever simple pendulum comes, and it comes in many different chapters, please do it, right? Kindly remember the formula. Hopefully everyone remembers the formula that time period for a simple pendulum is 2 pi under root L by G. Now the whole point is, in some chapters, my dear friends, please see, let me just give you a quick revision of time period of a simple pendulum. In some of the chapters where, like for example, is mechanical properties of solids or thermal chapter, in those chapter length changes, right? So time period is going to change because of length. In all the other chapters, small g changes, like for example, as in gravitation or in this chapter or some another chapter, right? Small g changes. For example, is in this one. First of all, you have got charge on pendulum. You have got like two charges Q and Q which are getting repelled by each other, and you have to find out the value of R or Q, whatever they are saying, right? So this is in equilibrium. This means that at this particular point, net force will be zero. Net force will be zero. Plus, please remember one very important thing, that if they are going to tell you something like this, that if theta is very small, how they are going to tell you this? They are going to explain that theta is very small by something like this, that R is far more less than capital L. wherever in question you are going to see that r is far more less than capital L, that means that theta is very, very small. And if theta is very, very small, then you can write down, instead of tan theta you can write down sin theta, and we know that this is sin theta, and we have got also, I mean hopefully you guys know how we have reached to this conclusion, right? This is tension T, this is going to be T sin theta, this is going to be T cos theta, and then after equating T sin theta to QE and T cos theta to mg, we can get to tan theta is equals to QE by mg, and instead of tan theta we can also write down sin theta, right? So this thing is very, very important, please note it down. And now the next thing is, all of these things are, by the way, in form of quotients in your note. Most probably it will be form of quotients in your note. Next thing is, let's suppose that if we drop this system down into another liquid of density, let's suppose rho, right? So if theta does not change on submerging in liquid, dielectric constant of liquid will be given by, directly use this formula, it will save a lot of time of yours. Else you will have to do this, and then in the next case you will also have to add a buoyant force, an upthrust, right? Got it? Are you following what I am trying to say? So instead of mg we will have to write down the apparent weight. So please note this thing, note this formula down. This is why I am keeping these classes for you, right? I'll after the class I'll get these notes to you, don't worry. Robin, let's decrease the sarcasm level. Let's not talk about all of these things in the chat, right? Be a little empathetic to yourself and to all the other students, right? It's not, do not get worried. If you are seriously worried, then please don't. We have got 1 week left. I mean, whatever you can do, please do. Give your maximum efforts and expect the best. In these 7 days you can revise whatever you have learned. If let's suppose you have some of the topics you have skipped it, so revise it through, complete it through formula revision. Do not start any complex topic right now, right? That's all you can do. I won't say that skip the entire chapter. Every chapter has got definitions, formulas, those things are easy in all subjects. In in biology you don't have formulas, maybe not that much, right? So each and every chapter have simpler stuff. So if you have got serious problem in rotational motion, don't skip it, revise it. Got it? Revise it. So this is not the time for you to just think about bad things. Expect the best and work for it, right? Let's quickly move on and see this is how you can do it. I mean, there is high probability, just let me, before moving on, let me just take 1 more minute. There is high probability that from these 3 classes, I have taken 2 classes for 11th class, formula revision, and in those formula revision I am simply not just talking about like this is one formula, right? This is one formula. Now let's move on to the electric field formula. We are not doing that. What we are doing is, from this formula we can have some questions like this. So we are also covering, so there is high probability that NTA can directly ask questions from here. So if you are feeling low, if you are feeling demoralized, if you are feeling slight fear, then in this time please revise as often as possible. Try to solve some PYQs, and then after every 2 hours have a walk, and that's it, right? That's it. I mean, you have done your best, and then give your exam and we'll see whatever our result is. And after that also we have got like ample amount of opportunities. I mean, it's not like that even if you are going to have the best rank in the NEET, from the next day everything is going to be extremely good, right? Still you have got struggle. So either ways, life is full of struggles and life is full of pleasures also, right? So do not live on extremities. Let's quickly move on. Now my dear friends, this is what I was trying to say, that what they can actually do is they can charged particle released in electric field. So if you have got a charged particle which is released in electric field, by the way I am going to talk about time period. I think that slide is somewhere else, right? So we have got force will be applied is QE, acceleration will be QE by m, velocity will be QE by m into t, velocity. What I am trying to say is that they can also club kinematics with electrostatics. There is high chance that they can include kinematics. Okay, so there is a high chance over here, and also please do something like this. I mean, in this case, my dear friends, what they are trying to say is that we have got electric field like this. We have got electric field like this, and then we have got a charge particle kept over here. And let's suppose we have just kept the charge particle, that means initial velocity will be 0. So after some time its final velocity will be given by v equals to u plus a into t, right? So I have given you one thing, now you can understand all the other formulas. Now in this case things are again slightly different but not difficult. Electric field is in this direction, my dear friends, and charge particle is thrown perpendicularly to the electric field. That means that you have got now over here, please remember that we have got acceleration in y direction, and acceleration in y direction is QE divided by m, and you have got final velocity in y direction as 0. You have got you have got acceleration in x direction as 0, and you have got initial velocity in x direction, that is given as u. Simple. So kindly apply again equations of motion in x separately and in y direction separately, right? So you are going to get, after some time, my dear friends, after some time, this velocity is not going to change because there is no acceleration in x direction. Vy will be written as 0 plus acceleration, that is QE divided by m into t, right? And then if you want to find out the final velocity, then magnitude will be under root u square, that is Vx square plus QE by m into t square, right? So QE by m into t square. Everything is going good, right? Done. Let's quickly move on to the next topic. All right. By the way, what will happen if an electron is accelerated opposite to, they are saying that an electron accelerates in the opposite direction of electric field, obviously force will be in the opposite direction to the electric field on an electron. Clear? Now again see, I have written some data over here that can save some of your time. Now please understand, if in these last few days, I'll also, while explaining these things, let me also tell you how you should use your brain, right? Because please understand, your brain, your memory it has got some limitations, right? Somebody might have a very good memory, somebody might have a very weak memory. What I'm trying to say is, let's suppose if you are feeling overwhelmed, then what you can do is you can just have a glance on these things. If let's suppose you are seeing some things for the first time and you are feeling slightly overwhelmed, then what you can do is you can have a glance on those things for few times before mugging it up. Got it what I'm trying to say? So if you are going to, if you think that I'm going to memorize all the short tricks that sir has given in this slide by today itself, that might not work. So what you can do is, by today you can have a 2 or 3 times have a glance on it. I mean to say, what do you mean by a glance? That you are just looking at it, okay, this is how it works, fine. Now let's move to those topics on which you have got a good command. Memorize them, use active recall method, solve PYQs, and after some time again have a glance on it. After few times, in a single day, after few times, your brain will be, now it will not get overwhelmed with the same thing again, and then you can memorize it, right? So this is how you should move in these last few days. Whenever you feel that this is getting too much, I don't know this, I don't know that, I have to learn this also, I have to learn that also, for a few moments, revise something which you already know, open your formula sheet, and the things which you are having trouble in, just have a glance on those things. Got it? So please understand, if you have got an electron and a proton, right? You have got an electron and a proton, and it is dropped in electric field. By the way, please remember that gravitational field, small g is 0 over here. So we have not taken small g into an account, that's why you are not seeing small g over here. So we have got, simply we have used s is equals to ut plus half at square, we have dropped it, so u is 0, and this is how we are going to form some equations time taken by an proton to fall h distance and time taken by an electron to fall h distance, right? Obviously we'll have to apply electric field in opposite direction. Also please remember some of the normal things. Those normal things are, my dear friends, that mass of proton upon mass of electron is 1837. Obviously mass of neutron and proton are almost equal. You can also assume it to be 2000. That means proton is 2000 times more heavier than the electron. So this is a data. If you ever need it, I have it for you. Please remember the ratio of charge of this is actually charge by mass, ratio of charge by mass. So this is also very, very important, and this is obviously this is for electron, right? This is for electron. So please remember it. Moving on, then again we have got neutral point. These neutral points are again formula is going to be same, but I have already given you the formula. This is again two shortcut formulas. I have explained it to you. Please use my original formula from the first slide. That is more simple. If you don't already remember this formula, alright, if you already know this formula, fine, you can use it, else you can use my formula. Can I move on from this? Now this is what I was talking about time period. I thought that in that slide we are going to discuss it. Time period, let's suppose you have got a simple pendulum, it is swinging, and then suddenly we have switched on electric field. So if electric field is switched on, and let's suppose this is a positive charge, so electric force will act in the opposite direction, QE. So my dear friends, one very simple thing, I have told you that time period is actually equals to 2 pi under root L by G effective. This is L by G effective, right? So please find out G effective. So G effective will be G minus acceleration in upward direction will be QE divided by M. QE divided by M. So that is why we have got time period like this. Now this is not what they are going to ask, right? They are going to ask whether the pendulum is slowing down or whether the clock becomes fast or it becomes slow. They are going to ask something like this. Correct? Clear? So see what you are going to do. If electric field is applied like this, denominator is actually decreasing, right? Denominator is decreasing. That means T will increase. If T increases, that means time period increases. If time period increases, that means clock is slowing down. Please remember it. If time period increases, clock slows down. Right? Same thing we have done in mechanical properties of solid chapter also, and in thermal properties also. Clear? Similarly, if electric field is going to go downward, you are going to have formula G plus QE by M. I am not going to explain it again. If electric field is applied in the X direction, my dear friends, right? If it is applied in X direction, then G effective will become the vector sum of G and acceleration due to electric field. Got it? So it would be under root of G square. That means inside under root you have got one more under root, and that is G square plus QE by M whole square. Please note here also denominator is increasing. That means time period will decrease. That means clock will become fast. So here also time period decreases. That means clock becomes fast. And over here also clock becomes fast. Hopefully everything is clear. Clear? Quickly write down in the chat box if everything's clear. Done. Can we move on to the next topic? Now we have got electric flux. See how many questions we have gone through till now from electric charges and fields, right? Now from electric flux is simple, phi equals to integral of E dot ds. Easy. Gauss law is easy. Phi equals to Q upon epsilon naught. If we have got zero flux, that means net charge will be zero. This is very important. Net charge will be zero. That means no charge is inside the cube in this one, because the amount of electric field lines which are entering, the number of electric field lines which are entering is equals to the number of electric field lines which are exiting from it. Charge placed at the center, total flux will be Q upon epsilon naught. Charge placed at one of the phase, then the flux will be Q upon 2 epsilon naught. By the way, in this one, if charge is placed at the center and we want to calculate the flux through only one phase, then from that one phase, my dear friends, from that one phase, like for example, as let's suppose we only want to calculate flux through this phase, so it would be Q upon 6 epsilon naught. right? Because total number of faces are 6, so it would be q upon 6 epsilon naught. If the charge is not placed at the center, but it is placed at the center of a face, it is not placed at the center of the cube, but it is placed at the center of a face, so it would be q upon 2 epsilon naught. I am not here for explaining these things, please remember it, but still if you are going to ask me any doubt, I will. Let's suppose that charge is placed at the corner, so it would take 8 such cubes to cover the charge entirely. That's why flux through one of the cube will be q by 8 epsilon naught. The important part is, let's suppose charge is placed at the corner of a cube and we want to find out flux through one face. So from one cube you have got q upon 8 epsilon naught, and that one cube have got 6 faces. That means is it correct? Quickly write down in the chat box. Be quick. Let me know if this is clear or not. Be quick. If this is clear or not, let me know. Be quick. Write down in the chat box. By the way, this thing is correct. So please note this formula also. This is very important. All right. This is very, very, very important. So for a cube, if it is placed at corner, it would be q upon 8. If it is placed at corner and we want to calculate it for the face, it would be q upon 24. Similarly, charge is placed at the edge, it would be q upon 4, and from a particular face, it would be q upon 16. Moving on, my dear friends, now you have got applications of Gauss law. Please remember all the formulas. Also, please remember the graphs from it, right? Ishika, do you have any doubt from the last thing, dear? Next is point charge. For point charge, everyone remembers the formula. Please remember the graph also. From a metal sphere basically means it's a conducting sphere. So at surface it would be kq by r square. On the outside it would be kq by small r square, and inside, please remember, metals have zero electric field inside the surface. Got it? Done. For non-conducting spheres, you have got inside. Now we'll have inside electric field also, and please remember that these formulas are very similar to what you have seen in gravitation chapter also, right? Class is till 3 p.m. My dear friends. All right. Right now it's 12:30. We have got sufficient time left. Ishika, just try to see that from one cube you have got q by 8 epsilon naught, because it took 8 such cubes to cover that charge completely. So always remember how many cubes are required to cover a particular charge completely. How many cubes are required? So 8 such cubes were required. Duration is, again, let me repeat, it's total of 3-hour class. Hopefully this is clear. This is exactly similar to gravitation. Entire thing is similar to gravitation. All right. Entire thing is similar to gravitation. Moving on, hopefully graphs are also clear. I am not explaining graphs to you, right? Next is, my dear friends, after this you have got conducting sheet. It is sigma upon epsilon naught. Many times students do this mistake. If it is conducting, it would be sigma upon epsilon naught. If it is non-conducting, it would be sigma upon 2 epsilon naught. If they have not said anything, if they have not said anything, assume sigma upon 2 epsilon naught, that is non-conducting sheet. All right. Next is, my dear friends, this is a formula which we actually find out using integration method, and that is electric field due to a line charge. That is 2k lambda by r times sine theta by 2. So please remember this formula also, right? And the next is, if you have got an infinite line wire. So we have got electric field as 2k lambda by r. Clear? What you can also write down over here as, if let's suppose this angle is theta 1 and this angle is theta 2. So you can write down the formula of E equals to 2k lambda by r times, or k lambda by r times sine theta 1 plus sine theta 2. All right. So now if you have got an infinite wire, then this will become sine 90, this will become sine 90, 1 plus 1, 2. So 2k lambda by r, you will get your formula. If you have got a semi-infinite wire, then one of them will become sine 0, another will become sine 90, and answer will become k lambda by r. Just half of that, right? Clear? Can we move on? Okay, please remember this thing, because many times students actually don't remember the formulas for for a ring or for a sector. Not a ring, for a sector. For a ring it is very easy, it's going to be 0. For a sector or for an arc, we'll call it as arc. If angle is theta, it would be 2k lambda by r sine theta by 2. Please remember, if you have got a complete circle, that would mean that means ring, that would mean that theta will be 360 degree. 360 divided by 2 is 180, sine 180 is 0, and that's what I was trying to say. Clear? Got it? Electric field due to an arc formula is 2k lambda sine theta by 2. So that means if you have got something like this, if you have got something like this, charge q, so this angle will be, theta will be 90 degree, and if theta is 90 degree, this is going to be sine 45 degree, and you can get the formula. It would be E equals to 2k lambda upon radius r, and this is going to be 1 upon root 2. So it's going to be root 2 k lambda by r, and similarly for a semicircle, theta would be 180 degree and electric field will be 2 k lambda by r. Please remember formulas like this in center of mass, right, in gravitation and over here. So gravitation and electrostatics are exactly same, just change charge with mass. Electric field at the center of a circular ring is 0. We have found out. This is also exactly equals to what we have seen in magnetism. So if we are not going to discuss these formulas in magnetism, that would be fine. Quickly write down in the chat box if everything's clear. Be quick, my dear friends. Also, see, there are lots of patterns in physics, especially in NEET, that you can use to save a lot of time as well as gain some confidence. Right now we are, if you guys are having a problem in confidence, please see the patterns. Wherever you will have a term like this, that E is equals to k q x upon x square plus r square raised to the power 3 by 2. Please understand what I am trying to say, that electric field in this case is actually proportional to x upon x square plus r square raised to the power 3 by 2. And we want to find out the maximum value of electric field. Wherever you are going to have a function like this, that maximum magnitude will be attained at r divided by root 2. Got it? Same thing for gravitation also. Yes, if you are somebody, Amu is asking me, sir, after watching formula video of 11th and 12th, can we solve PYQs with mocks and can attempt 25 questions correct in physics? Please see, I can definitely say for 25 questions, definitely, but 25 questions would not be that much, right? 25 is like 100 marks. So you can even get 30 to 35 question correct, even if you have a your basic concepts are clear, you have solved some questions from PYQs, add some questions from JEE mains also. 7 days is fine amount of time, right? You can do it, right? I can't say it for like you can solve 40 questions, because definitely 10 to 15 questions are going to be of above moderate difficulty level. For that you must have certain practice, but with formula revision you can easily crack formula revision plus PYQ. You can easily get 20 to 30 questions, right? So this is clear. I'm moving on. I have explained a very important thing. I don't know if you have got it. Let me know in the chat box. You are going to see this many times in physics, right? And this graph also. So remember this. Now let's quickly move to our next chapter, that is electrostatics, potential and energy. If you are thinking that, sir, what about dipole? We are going to do dipole in this chapter. Now please tell me, have I skipped a single thing? There might be some formulas over here, there might be some notes over here that you might not have seen earlier, right? So we are going through each and every topic. Please remember electrostatics, potential, energy. Just remember the formula K Q1 Q2 upon R. If it is going to be an attractive force, then potential energy will be negative. If it is going to be a repulsive force, potential energy is going to be positive. It is going to be same for gravitation. It is going to be same for anywhere you are going to hear potential energy, right? Concept of potential energy is same. So do not worry about these things. Again, this is repetitive. If this thing again is repetitive, you are going to see the same thing in gravitation. Moving on to the next thing, system of charges, if you have got 4 charges, what is the work done in assembling those charges, what is the work done in disassembling those charges, this is going to be the potential energy of the system. These are the number of pairs that you are going to form if you have got n charges. Got it? So let's suppose you have got 4 charges, so the number of pairs you are going to get is 4 multiplied by 4 minus 2 divided by 2. So this is going to be 2. So this is going to be 2 multiplied by 3, that is 6, total 6 pairs. So 1, 2, 3, 4, 5, 6, right? And then you can save a lot of time. That means that this pair and this pair and this pair and this pair, these are same. If let's suppose Q1, Q2 all are same. Hopefully you are getting it what I am trying to say. So please remember this thing. Also some of the easy things, that diagonal has length r by root 2. If you have got a cube, my dear friends, let's suppose you have got a cube, right? And in cube you want to find out, in cube, my dear friends, please, this is known as phase diagonal. This is known as main diagonal. This is known as main diagonal. So the length of the main diagonal is root 3a. The length of the phase diagonal is root 2a. Got it? So remember these basic things before your exam. In NEET, no one should feel ki what is the value of phase diagonal, I am not getting. These are basic class 10th level geometry that you must remember, right? Phase diagonal is like class 6th geometry, I don't know. So work done in rearrangement of the system, it's going to be change in potential energy. Everyone knows this. Please remember again some of the basic things. Work done by external force is actually equals to negative times of change in potential energy. I am so sorry. Work done by conservative force is equals to change in negative times of potential energy, and work done by external force is equals to simply change in potential energy. So they are going to obviously in these types of questions they are going to talk about external force. So simply find out the change in potential energy. Be quick, clear, repeat again. I don't understand. Fine. Sorry. Abhishek, tell me the topic which you are asking about. Quickly let me know the topic. I'll explain it again. This is an example in front of you. First find out the initial potential energy, find out the final potential energy, know the difference, you will get to know the work done. Yes, Amu, I have explained your doubt. Please don't ask same question again, my dear friend. Then we have got electric dipole. For electric dipole, we have got electrostatics potential. Just remember the general formula for electrostatics potential. Right now we are talking about electrostatics potential only. This is the formula, that nothing's too tough about it. We have got dipole moment, very easy. If you're going to ask your doubt, I'm going to explain it. All right, Abhishek. Next is, my dear friends, this is important. This is what I was trying to say. Remember the general formula of everything. Instead of remembering each and every formula, if you have got any doubt, although most of the students remember this thing because this is a very important topic for boards also. So this is the general formula for electric field. Please remember, please solve some good questions from dipole. Solve some good questions from dipole. They can ask questions from here and it can be a little tricky. Got it? Like for example, as two dipoles are inclined at certain angle, or one of the dipoles, and when they say that two dipoles are kept on a Cartesian plane on this and that coordinate, do some problems like that, right? Clear? Hopefully no more doubts. If anyone is going to ask me any doubt, I am going to explain it. Please use the chat box. My dear friends, hopefully everything is clear. With axial and with equatorial, simply put down the values for theta. If we are talking about axial, theta will be 0, and if you are talking about equatorial, theta will be 90 degrees. Similarly, this is the formula for potential, right? Potential, general formula for potential again for axial and for equatorial. Clear? For torque, torque will be PE sine theta. And then whenever you are going to talk about torque, please remember, please remember that you can also talk about time period, because after this, my dear friend, hopefully we are going to discuss potential energy of the dipole also, that is stable equilibrium. And whenever they are going to talk about stable equilibrium, they are going to also talk about time period. So time period is equals to 2 pi under root 2 pi, basically it is 2 pi by omega, and omega can be written as, my dear friends, k by m or m by k over here, right? So instead of m, we won't be writing m over here, so we are going to write it down as moment of inertia and divided by PE. Please remember these formulas, do not skip it. This is where NTA can actually increase a level. Let me again tell you, before NEET 2025, this was the level of question that find out the stable equilibrium case, find out the angle at which stable equilibrium will be there, find out the work done, simple things. Now what they can do is they can ask about time period of a dipole, electric dipole. Got it? So do not skip these things. Dipole is 2 pi, time period is 2 pi by omega, and again these things have a pattern. Why don't you guys get it? If you are going to only study 10 chapters, right now, if let's suppose you are getting worried in physics, take 10 chapters in your hand, right? Take some of the chapters from class 11th, take some of the chapters from class 12th, which are conceptual chapters. On the other hand, keep modern physics ready, keep units and dimension ready, keep semiconductor ready, all of those things. And on the other hand side, take electrostatics, gravitation, work, power, energy, Newton laws of motion, where you can actually solve some questions from PYQs. Got it? So this is all clear. The time period formula is same. Potential energy is going to be minimum in stable equilibrium. Now I'm not just talking about electric dipole. The definition for stable equilibrium is that at stable equilibrium potential energy is minimum. For unstable equilibrium potential energy is maximum. It will be same for all the other things. Wherever you are going to hear that we have got an unstable equilibrium, remember potential energy will be maximum, right? Unstable means that it wants to become stable. It is unstable, and unstable has got lots of energy. Same thing, same in modern physics. The electron in the ground state has the minimum energy, minus 13.6 electron volt for a hydrogen atom. As it will move up to the excited state, it will become unstable, and it would want to come to the ground state, and it will throw off the radiation. So things are interconnected. Do not try to assume that I have to study entire electrostatics, then I have to study entire gravitation. Many things converge, right? Moving on to the next thing. Then we have got, my dear friends, potential of a charged conductor. Please remember one very important relation, that electric field can be written as minus dV by dr. Again, my dear friends, this is also same. Whether you are going to talk about electric field, this is electric field, this is potential gradient. This is potential gradient, right? All of these things have come from our F equals to minus du by dr. Got it? Minus du by dr. So gravitation has got the same thing, electric field has got the same thing, right? And then again integration of dv will be integration of E dot dr. This is called as line integral. This is again same in gravitation. So things are same. So inside, because electric field is 0, potential will be constant. Potential will be constant. Moving on to the next one. If you have any doubt, do let me know. Clear? Everything is sorted? Can I move on to the next thing? This is what I was talking about in slide 1. That is redistribution of charges when you connect two spherical conductors, right? Two conductors. So in this one, again use the concept of common potential. This is the major concept, and we are going to use it in capacitance also. But for you can quickly remember the general formula also, sorry, the short trick also, that q1 dash upon q2 dash will be equals to r1 upon r2, E1 upon E2 equals to R2 upon R2, sigma 1 upon sigma 2 will be equals to R2 upon R2, and the basic concept is conservation of charge, that q1 plus q2 will be equals to q1 dash plus q2 dash. That means there will be conservation of charge over here, because this is an isolated system. After doing all of these things, potential will become same, that is k q1 dash upon r1 equals to k q2 dash upon r2, and from here you have got to know that q1 upon q2 will be equals to r1 upon r2. Got it? Hopefully everything is clear, my dear friends. Be quick, write down in the chat box. See, these formulas are going to save a lot of time for you. Moving on, then we have got equipotential surface. As I have already told you the relation between electric field and potential. Now please see that this is E equals to minus dV by dr, or E can be written as in the partial derivative form, minus del V by del X minus del V by del Y minus del V by del Z. Equipotential surfaces are those potential surfaces where on these surfaces each point have same potential, right? That's why they are called as equipotential, and equipotential is always perpendicular to what? Electric field, right? Now the thing is that this relation basically tells us that electric field decreases in the direction of potential decreases in the direction of electric field. That relation, the negative sign says that potential decreases in the direction of electric field. Like for example, is if electric field is in this direction and if you have got point B and point C, then definitely C is in the direction of electric field, then potential at C will be less than potential at B, and B and A have same position with respect to electric field, right? There is no change in X. Why I am talking about X? Why I am not talking about Y? Because electric field is in X, right? So electric field is in X, so I am going to talk about the X coordinate of point A and B and C. So A and B have same electric field and C has the least electric field. Got it? I have explained all the things from here. Be quick. Let me know quick. Done? Can we move on to the next chapter now? Next chapter means capacitance, not current electricity. Capacitance is very important. Electrostatics potential is not that much important, but capacitance is very important because NTA has been doing this, that it has giving regular questions from capacitance chapter, right? So now, and it has got lots of trick formulas also, shortcut formulas. Let's quickly move on. Be quick. So the main some main concepts of capacitance are written over here. Formula for capacitance in different ways. C can be written as Q by V, Q can be written as CV, C can be written as epsilon naught A by D. This is the capacitance for a parallel plate capacitor, of course. If you have got a spherical capacitor, things will change. This is actually important. Please note these things. They can ask something like this also. Capacitance depends upon the distance, area and medium. It is independent of charge and potential, of course. SI unit is farad. Next is, my dear friend, electric field between the two plates of a parallel plate capacitor. Electric field is obviously sigma upon epsilon naught. Everyone knows it. Potential is this. Everyone knows it. Why I am moving fast? Because these are simple things. Finally, this is again important, that is force between the plates of a parallel plate capacitor. Do not try to derive it. Please remember it. CV square divided by 2D. Right? So you have got formula of energy as half CV square. So half CV square divided by D becomes the formula for force acting between two plates of a parallel plate capacitor. Think like this, right? Think like this. Moving on, my dear friends. Then you have got work done by a battery. See how important this formula sheet is for you for revision. Work done by a battery is QV. That means battery is doing 100% of work. What do you mean by 100% of work? Let's suppose battery is doing 100 joules of work, right? And that is written as Q into V. Now, out of that, this 100 joules, the energy that is getting stored in the capacitor is half CV square or half QV. That means it can only store 50% of the energy, and 50% will be dissipated in the form of heat. So please remember it. If someone asks you what is the energy dissipated by the battery, or what is the energy not dissipated, what is the energy given by the battery, so it would be CV square, half of what is stored in the capacitor, right? So hopefully this is all clear to you. Variation with plate separation, that means what will happen to C, what will happen to E, what will happen to V if you are going to change the separation of the plate. My dear friends, Q depends on D, something like this. C depends on D in an inverse fashion, and again potential depends on D with a direct relation, E depends on D with an inverse relation, force depends on D with an inverse relation, potential energy depends on D with a direct relation. So remember all of these formulas. Please try to understand, these are not different formulas, but we have simply Q equals to CV, so C can be written as Q by V. That's it. So it's not a lot of work for you to do. Is everything clear? quickly let me know. Now the next thing is, what will happen, again this is very important, what will happen that if let's suppose we have got a capacitor like this, if we have got a capacitor like this, and you have a dielectric over here, and by the way dielectric is fully, we have completely filled this parallel plate with a dielectric of dielectric constant K. So what will happen? There are two cases, please mind this thing. One is if battery is connected, what I am trying to say is battery remains connected and you have filled the plates with some dielectric. Second case is that you have filled the plate and you have disconnected the battery. This means that, please remember that if battery remains connected, that means that potential will be constant. And that means charge will not remain constant, because the role of a battery is to maintain the potential difference and to give charge, to provide charge, to supply charge. So that means new charge will keep on coming and potential will remain constant because battery is still connected. If battery is disconnected, that means now the potential cannot remain same, right? But now there is no source of new charge, that means now the charge will remain constant. So these are the two things, please remember that if they are going to talk about that what will happen to this, what will happen to that, if I have inserted a dielectric in a capacitor, right, a completely filled case. So in that case, please remember one thing, if battery remains connected, that means potential will be constant, so charge cannot remain constant. Second, if battery is disconnected, that means potential cannot remain constant, now charge will remain constant. If everything is clear, quickly write down in the chat box, be quick. Sorted. Second thing is, always remember that capacitance will always increase, right? By the way, here they have also done one thing, that they have changed D to 2D and D to 2D. So that means in both the cases capacitance will decrease. In both the cases capacitance will decrease, and then so on. Hopefully you have no doubt. I am not going to waste a lot of time in explaining each one of them, because you already know how these things are changing, right? I think they are right now on this slide, they are not talking about dielectric, they are talking about separation with D, but this thing remains the same, concept remains same. In the case for dielectric, my dear friend, what will happen along with these two cases, please remember capacitance always increases by K times. Clear? Got it? Be quick, let me know in the chat box. Moving on, dielectrics in capacitor. If you have got a completely filled dielectric, capacitance will be K times of C. If you have got a partially filled dielectric, please remember this formula. And even better than this, please remember this formula. I think in NEET 2025, again they have asked a question from this, if I am not wrong. I'll have to recall. So this is epsilon naught A divided by T by K1, T2 by K2, T3 by K3, and please remember, for a metal K is infinite. So if they are going to talk about, like we have inserted a copper plate inside a capacitor, a parallel plate capacitor, its capacitance, sorry, its dielectric constants will be infinity, and that will be written as, let's suppose they have the thickness of that dielectric is D by 2. So it would be D by 2 divided by infinity, it will become 0. 1 upon infinity is 0. Got it? Everything is clear? So this formula is very, very, very important, because it will save a lot of time. Even if let's suppose we have got, if you want to use it for this, so this is T thickness, the remaining thickness is D minus T divided by dielectric constant of air, dielectric constant of air is 1. These are some basic things. Please remember it, dielectric constant of air is 1. Hopefully everything is clear. Moving on to the next one. Now this is what I was trying to say, my dear friends, that if dielectric is inserted and battery is removed, my dear friends, if battery is removed, then charge will remain constant and potential will not remain constant. And please remember, in both the cases capacitance always increases. So again I am telling you, in these last 7 days you can get physics also, and that will help you a lot in your main rank, because physics is again filled with lots of patterns, and I am not talking about some like patterns like without concepts. We have got concepts over here. Like for example, is you can just remember it that if dielectrics is inserted, capacitance will surely increase. Now what happens if you remove a battery or battery remains connected? So if battery remains connected, that means potential will be constant. So if potential is constant then capacitance is increasing, you can directly write down that charge will be written as C dash into V. Now V does not change and capacitance increases. So that means Q also increases. So Q will also increase and so on. Clear? So these things are very important. Again, let me tell you, I am moving on. I am not explaining for energy and for energy stored and for potential energy stored. And by the way, this is electric field. This is not energy. This is electric field. This is potential energy. Right? Clear? Everything is clear. I have given you all the formulas in the previous slide, so you don't have to worry about these individual formulas. Moving on, my dear friends, now we are going to talk about spherical capacitors. Spherical capacitance is simply written as 4 pi epsilon naught multiplied by R1 R2 divided by R2 R1. This is spherical capacitor. Got it? Hopefully you are understanding how we have written it. This will be again written as C equals to Q divided by potential difference. That means Q divided by potential of V1 minus V2, because V1 will be at higher potential, V2 will be at lower potential, my dear friends. If you are going to substitute, you are going to get this. For capacitance of a spherical capacitor, this is the thing that, this is the formula that we are going to get. See. How much time you are going to save in these types of question. Haven't you seen lots of questions on distribution of charge in these things in which they say that n drops coalesce together, 64 drops coalesce together to form a one bigger drop, isn't it? So simply use these formulas that if n drops coalesce together whose potential of one drop was V, charge of one drop was small q, capacitance was C, radius was smaller. So first of all find out the radius of the bigger drop. And haven't they used radius? Okay, if they haven't used radius, let me write it down for you. 4 by 3 pi into r cube multiplied by n equals to 4 by 3 pi into capital R cube. My dear friends, quickly remember it. You are going to use it at many places. And my dear friends, capital R will be equals to n raised to the power 1 by 3 into small r. This is one more formula. And after this, please remember this. Q dash will be simply the charge is a scalar quantity. Simply add all of the charges, n times q. Capacitance will be n raised to the power 1 by 3 into C and so on. Potential and for energy also, that is energy stored. Is everything clear? Write down in the chat box. This is very important. You might have also seen it. Done? Clear? Be quick. And then we'll move on. Clear? Next is when you are connecting two capacitors. When you connect two capacitors, charge flows from higher potential to lower potential till both of the capacitor have same potential, common potential. So this is very important. When the positive side is connected to positive side, this is again important. NTA can actually play with you in this, that they can actually connect a positive terminal with negative terminal, and most of the student will apply the same formula. So this is a general case. This is the traditional case that you might have seen. Common formula, potential common formula is very simple. This is again a very normal thing, so I'm not going to waste a lot of time. This is a topic in your notes, right? So everyone has it. Got it? Next is initial potential energy and final potential energy. Don't try to remember these things. Simply remember the energy loss, because this is going to be very important. And then the next thing that they can do is they can ask what is the charge flown in the circuit. So that is going to be slightly important. If they are going to ask what is the charge flown in the circuit, so please remember, after the capacitance have arrived to the common potential, after the capacitance has arrived to the common potential, still it has got capacitance C1, it has got capacitance C2, now it has got potential VC, it has got potential VC. Got it? So now let's find out Q1 dash. So Q1 dash will be, my dear friends, this is C1, so it would be C1 into VC. Q2 dash will be equals to C2 into VC, right? C2 into VC. Now, my dear friends, you can compare it with Q1 and Q2. So Q1 will be C1 into V1, Q2 will be C2 into V2. What I am trying to say is, let's suppose that Q1 was 20 microcoulomb and Q1 dash is actually Q1 dash is actually 15 microcoulomb. What does it tells you? It tells you that 5 coulomb of charge has flown from C1 to C2. 5 microcoulomb of charge has flown. Got it? So you can do some questions like this also. Clear? Okay. Let me know. Just a second. Let me fix this light. Be quick. Next is this, my dear friend. This is what I was trying to say. Let's suppose positive terminal is connected with negative terminal, then common potential formula will be slightly different. It will become C1 V1 minus C2 V2 divided by C1 C2. All right, clear? And then you will have a formula for energy losses. Instead of V1 minus V2 whole square, it would be V1 plus V2. Over here we have got V1 minus V2. So again, this is where you are going to use formula sheet. Got it? This is where you are going to use formula sheet, because in these cases you might get doubt in your final NEET exam. I'm not talking about this particular case because this is a very famous formula. It is used in boards, it is in your notes, it is in NCERT, it is everywhere, it is like a topic. But I'm trying to say that this is where you will use your formula sheet revision to get a better clarity, right? Next. So this is all clear. Hopefully I'm not going to explain anything else in this. Now you have got grouping of capacitors, and then voltage divider rule. Obviously voltage will be inversely proportional to capacitance, right? So this is also all good. I'm not going to waste time in series combination or parallel combination. Everyone knows this. Or charge divided rule. I will please note the charge divided rule, current divider rule. If anyone has any doubt in this, I will explain it in current electricity. Got it? So hold on. In current electricity, I am going to explain you current divider rule. It is same as this. And please note that in NEET 2025, they have asked a question in which question you are going to use current division rule. Got it? So we are going to see that also. Next is, if we have got multiple dielectrics and they want us to find out K equivalent. So if they want us to find out K equivalent, this is the formula. If dielectrics have thickness D1 and D2, and this is the formula if they have got thickness D by 2 and D by 2. Basically this is just a general formula and this is a specific formula, right? And similarly, if dielectrics are connected like this, my dear friends, the difference is this is the series combination, right? And over here we have got parallel combination. So please remember, for parallel combination, K equivalent is summation of Ka divided by summation of A. So this is going to be the formula for dielectric. Everything is clear? Quickly write down in the chat box. Be quick. Done? Clear? K equivalent. And before that we have completed C equivalent. Now let's start electric current. Now we can talk about electric current, our next chapter. My dear friends, definition of current, formula of current is all good. This is the relation between current and drift velocity. I am going to again explain it to you. Do not use this formula of drift velocity. Let me change it, because I'll tell you why. Because they have used in this specific formula, they have used second equation of motion, but it is also correct, but generally now we all use first equation of motion for this. So for drift velocity, use Vd equals to minus EE, obviously I'm talking about vector form, minus EE tau by m, right? So the only difference is that in this you have got 1 upon 2 EE tau by m, right? So the 1 upon 2 EE tau by m. So instead of 1 upon 2, use this formula. This is slightly better. Now my dear friends, factors affecting drift velocity. We know how to write down drift velocity, right? So drift velocity depends upon electric field. If electric field is uniform, then Vd will be uniform, Vd will be same, Vd1, Vd2, Vd3 will be same. In this case, please remember electric field at region 1 is more than 2 than 3. Why? Because electric field density is more at region 1. So similarly, Vd is directly proportional to E, so drift velocity at point 1 will be more than point 2 than point 3. But there is a very important thing to note, that in these types of questions now, situations can be a little tricky. I'll give you one trick for this. Please understand what I'm trying to say. This is very important. Usually in question they start something like this. They start with, let's suppose we have got two different questions, okay? And they are talking about drift velocity. Why I am discussing this? Because see, drift velocity, one of the formula for drift velocity is, if I am going to talk about the magnitude, it is EE tau by m. And the another formula is I equals to NEA into VD. And VD is actually equals to I upon NEA. Now many times students actually get confused with these two formulas. They actually think that in this formula, we have got no direct relation of area, and in the second formula we have got a direct relation of area. So what I am going to tell you is, if you want to use those two formula, I will tell you one thing. If the question starts with a constant current I is flowing, please remember what I am trying to say. If a constant current I is flowing, then use this formula. And that means in that question, drift velocity will change with d. And if the question says a constant potential difference is applied, then use this formula. So these are the two different types of questions that you might get. Clear? Now moving on to the next thing, that is Ohm's law. Please see, I have written each and everything from Ohm's law from here. This is all clear. This is all class 10th stuff. Resistance is equals to rho L by A. They are talking about T1 upon T2, slope equals to tan theta, and that is equals to R. That means over here they are probably talking about this graph. A graph in which we have got V over here and we have got R, and it is the thing is showing ohmic behavior like this. It depends upon material, that means N and tau. It depends upon temperature, temperature changes N and tau, and it depends upon the dimensions. Please remember that N changes only for semiconductors, not for conductors, right? And with increase in temperature, that we are going to talk about later in alpha, right? You guys know what I'm talking about. Depends upon the resistivity, depends upon material, that is N and tau, and it depends upon temperature. So this is also very, very important. And please note down the formula also, m divided by Ne square into tau, and for resistance also it would become ml divided by A Ne square tau. Clear? Write down in the chat box if you have any doubt. If you have got a non-ohmic conductor, right? If we have got a non-ohmic conductor, then we could have like different cases for this. For example, you have got V, you have got I, and then they are saying that Vi graph is not linear, fine. Resistance is not constant, slope is positive, and resistance is also positive. So when V is increasing, then I is also increasing. So slope is positive basically means that we could have a graph something like this. Got it? We could have a graph something like this. That means slope of Vi curve is increasing. Similarly, then slope can become 0, right? So slope can become 0. That means so this is the slope, it becomes 0 at a particular point. Or slope is negative, like for example, as from this point to this point, slope is negative, my dear friends. Correct? All right, then you have got temperature dependence of resistance. As this is what I was telling you, that for metals, temperature dependence is something like this. That means if you are going to increase the temperature, if temperature is increasing, then relaxation time will decrease. If relaxation time decreases, then tau rho increases, resistivity increases. Because of that, resistance increases, right? And number of electrons, number of free electrons is actually does not change. So for metals alpha is positive, that means for metals with increase in temperature resistance will increase, and for semiconductors alpha is negative, right. So that is why the graph between resistivity and temperature for semiconductor will be like this, and for an alloy or for some metal it would be like this. Please remember, if you have got an alloy, then the value of alpha will be very, very small if you are going to choose an alloy like that, right. So that's it, and this is the variation of alpha for resistance. That means you can again rewrite this formula of R equals to R naught times 1 plus alpha into delta T. Now again, please see how many things are common in physics. This is the same formula that you have seen in thermal properties chapter also, right. So this is what I was trying to say, that things are very, very same. Hold on for a moment and think about it, that it is not, at least covering the entire syllabus is not that much tough, right. I can understand that definitely we cannot just rely on these formula, but the first case is to remember each and every formula. Then the next step is going to be solving PYQs, then the another step is going to be solving PYQs of some good difficulty level, right. So you can choose some mains questions from there. Clear? Write down in the chat box if everything's sorted. Now let's move on. So hopefully this thing is clear. Now let me tell you again, this is a particular question that they have asked in NEET and in JEE. Let's suppose that you are connecting two or more than two wires, and their alpha, that means their temperature coefficients are alpha 1 and alpha 2. So alpha equivalent for series combination will be simply this. That means alpha R1 plus alpha R2 divided by R1 plus R2. So let's suppose that R1 and R2 are same, so all of these things can be cancelled out, and please remember this case only when R1 and R2 are same. And again for parallel combination this is going to be the case, and if again R1 and R2 are same, then alpha will be equals to alpha 1 plus alpha 2 divided by 2. If you remember in the last class, okay, that I have not taken that class on this channel, but some of you remember that we were solving a question like this in which answer was alpha equals to alpha 1 plus alpha 2 divided by 2 for series as well as for parallel, right. It was from recent PYQ of mains or of NEET. My dear friends, now let's talk about current and voltage divider rule. Now this is very simple. Please remember that let's suppose you want to, this is the total current I, and if you want to find out the current flowing in this R1 resistor. So simple technique is write down the total current. Write down the total current. I'll give you one example also. Let's suppose that 15 ampere of current is flowing, and you have got you have got 2 ampere and you have got 4 ampere. And let's suppose you want to find out the current that is flowing in this 2 ampere wire. So I want to find out I1. So what you need to do is first write down the total current, then write down the value of resistance which is other than this 2 ohm. So that is 4 ohm. So 4 ohm and divided by sum of these two resistance, that is 2 plus 4, that is 6. So this is going to be, that is 10 ohm, sorry 10 ampere. So this will receive 10 ampere of current, and this will receive 5 ampere of current, right. And in the similar way you can find out the voltage divider, and same thing applies for charge divider also in capacitance chapter. Everything's clear? Please note, this is very, very important. In NEET 2025 they have asked a question from here. I mean not a direct question from here, but we have to use current divider rule in that. Next thing is again a particular topic which will save a lot of time of yours if you are going to use these shortcut formulas, that is cutting and stretching of wires. See, if you are simply cutting the wire, then resistance is directly proportional to length. And if you are stretching the wire, then things are slightly different, because then with change in length there is also change in area. So please remember volume remains constant, and because of that simply use this R1 upon R2 is equals to this ratio. So they are saying that initially area was A1, then it become A2, length is L1 and then it becomes L2. So R1 upon L2 will be equals to square of L1 and L2, square of A2 upon A1, square of, and then R2 upon R1 whole raised to the power 4, or D2 upon D1 whole raised to the power 4. So this is very, very important. If length becomes n times of length, then R becomes n square R, right? So please note this. If R becomes R by n, then R becomes n raised to the power 4 into R. And then this is percentage change. So my dear friends, I am not going to again explain percentage change in this. Please remember, whatever you have done in units and dimension, formulas are similar. Please note one more thing, that if the percentage change is very, very small, like for example as less than 5% or less than 10%, then you can directly use the approximation formula. Got it? So again, this is very important. Do remember it. This is going to save your time. Moving on. Then my dear friends, you have got cells and internal resistance. So cell have got EMF, right? And then we have got another thing is terminal potential difference, which over here it is written as TPD. So please remember that if we have got an open circuit, if current is not flowing, then terminal potential difference is actually equals to EMF, right? And if let's suppose current is flowing in the circuit and the battery is getting discharged, if the battery is getting discharged just like this, then in this case terminal potential difference will be less than the EMF, right? Terminal potential difference will be less than the EMF, and it would be something like this. Terminal potential difference will be written as EMF E minus I into R. Clear? And if let's suppose, now most of the students actually skip the third case in this, or they don't remember the third case. The third case is that let's suppose if you have got, if a particular cell is getting charged, if a particular cell is getting charged, then in that case EMF will be less than the terminal potential difference. So most of the time students do this mistake, that they think that always EMF will be greater than the terminal potential difference. That's not the case. Please remember the entire concept. It will be less than the terminal potential difference when when cell is getting charged. If it is getting discharged, then it's fine, then terminal potential difference will be small. Now my dear friends, let's move on. Hopefully no doubts. Quickly write down in the chat box. Everything's clear? Done? Sorted? Please. Next is, when cell is in open circuit, then terminal potential difference will be equals to E, right? And current is 0. This is open circuit, and when cell is short circuit, then terminal potential difference becomes 0. If it becomes a short circuit, then it is 0. All right, clear? Moving on to the next one. Please remember this graph also. Graph between current and potential difference, right? So internal resistance will be E minus V divided by V into R. All of these things are pretty common. And this is the formula for power. Maximum power is E square divided by 4R, and it becomes when internal resistance is equals to small r. This is the maximum power delivered theorem, and this is the maximum power. Most of the time students remember that maximum power is delivered when small r is equals to capital R, but they do not remember that what is that maximum power. And by the way, that is very simple. So maximum power will be E square divided by 4R. Also remember the graph for it. Now these things are those topics in which you don't have to really spend a lot of time in remembering these graphs. Everyone knows this thing, that small r is equals to capital R for maximum power. Now if this particular topic, if you are going to only see this graph and they are going to ask anything from there, you will be able to recollect it from your memory, that okay fine, this is how the graph looks like, right? So again do this. And then my dear friends, the next topic is combination of cells. First one is series combination. Most of the time they might give you identical cells, but if you don't have an identical cells and these cells are rightly connected, that means positive terminal of one battery is connected to negative terminal of the second cell, not battery, second cell, right? And so on. So this is known as correct way of joining them. That means E equivalent will be E1 plus E2 plus E3 and so on, and R equivalent will also be in series combination. So finally current will be net EMF divided by total resistance. So total resistance will be load resistance plus sum of internal resistances. Next thing, my dear friends, if let's suppose all of them have same EMF, that means this will become NE, this will become NR. So the current will become NE divided by NR plus capital R. Let me know in the chat box if you have any doubt. Correct? Now please see. The important concept over here is these two cases. The first case is if NR is far more greater than capital R. If NR is far more greater than capital R, that means we can ignore this capital R. That means this current will become NE divided by NR. N and N gets cancelled out, we have got E upon R. This means that if let's suppose you have got cells whose internal resistance is very high, you have got cells whose internal resistance is very high. So there is no use of connecting them in series combination to get a large value of current. You are not going to get large amount of current. Why? Because their internal resistance will become quite high, right? So you guys can also see if internal resistance is high, then current is simply E by R. My dear friends, current of E by R is the current which you will get from one particular cell. Let's suppose that if internal resistance is not high but it is far more less than capital R, then the net current becomes N times of E by R. That means now it is useful to use series combination. So they can ask a question like this, that which is the favorable case for a series combination and which is for parallel combination. Got it? In my class I have made you write this point. And then power dissipated is again the same formula, and maximum power also, my dear friends. Please remember these two things also. Quickly write down in the chat box if you followed what I tried to say, because I am not going to repeat the same thing in parallel combination. In parallel combination, this is the formula for E equivalent, this is the formula for R equivalent. Remember, for parallel combination you might spend some more time in memorizing it if you haven't done it till now, right? Next thing is power dissipation will be again I square R, and maximum power condition will remain same, that is capital R equals to small r by n, because R equivalent is small r by n. Clear? All good? Sorted? Let me know. The last thing from combination of cells is mixed combination. In mixed combination you will have, let's suppose you have got n cells in series and then you have got m such rows in parallel combination, right? So in this case, my dear friends, this is how the formula will look like. The R equivalent will be something like this, that is NR divided by M. Please see how each of these branches will have R equivalent as N into R, and these are M times. So that means finally the R equivalent will be N into R divided by M, because there are M cells. If you have got two cells in parallel combination, we write it like this, na, R upon 2. So if you have got M cells in, if you have got M branches and each of these branch has NR resistance, so it would become NR divided by M. So it has become NR divided by M, my dear friend. And total EMF is simply N into E, because each of this branch has EMF N into E. Clear? Right? The next thing will be current. So current will be E net divided by total resistance. Total resistance will be R plus R net. So we have already found out R equivalent, small r equivalent, that would be NR divided by M. Clear? So these formulas are also important. Moving on. Now remember the R equivalent, although they have deleted combinations of resistors as far as NTA's official website is concerned, but do not skip this topic entirely. So this is, you can remember for a infinite ladder where all the resistance are equal, and resistance are something like this, R1, R2, R3, right? And then same R1, R2, R3, R1, R2, R3 for this. Please see if they are going to change the ladder, do not use the same formula, right? Of course. Moving on. Now again I have got some more illustrations for you to remember, like for example is for a cube, when the when the current passes through something like this, from this point and from this point, then the R equivalent becomes 7R by 12, and in the case for A and B, which are phase diagonals by the way, so it becomes 3R by 4. So 7R by 12 and 3R by 4, and then the next thing is from the main diagonal. For main diagonal it is 5R by 6. Got it? So for main diagonal, phase diagonal and adjacent edges, adjacent corners, sorry. So remember R equivalent for these things. Now we have completed this chapter also. Do you have any doubt till here? Be quick, my dear friends. Any doubt? Can we move on? Done? Sorted? Now let's start our next chapter, that is moving charges and magnetism, right? In moving charges and magnetism, again the first law is Biot-Savart's law. Very easy, very basic. Remember the formula, remember the law also. Derivations, now there is no need of doing any derivation. Do not do it, but please remember its vector form. I have not got a vector form over here, so I'll write it down for you. dB is actually equals to mu naught upon 4 pi. Then you have got I R cross dl, sorry, dl cross r divided by r cube. Please remember one thing, wherever you are going to find out any law, like for example as Coulomb's law, Biot-Savart's law, and if it has got a vector form, do remember the vector form, right? They can ask anything regarding that vector form. So this is dl cross r. IDL is a vector quantity. Please remember current element is a vector quantity, and it goes like this: IDL cross R. DL cross R. That's why on P point magnetic field is inwards. And then we have made our rule for ourselves as a trick, as a right hand thumb rule. But in reality it is actually IDL cross R, and then it becomes IDL R sine theta divided by R cube. So one R and this R cube gets cancelled out and it becomes R square. Clear? And theta is the angle between current element and position vector. It is angle between current element and position vector. Current element is a vector quantity, and the direction of current element is along the direction of current, whereas current is a scalar quantity. Got it? But current element is going to be a vector quantity, and it is IDL. As well as length is a vector quantity. Just like area is a vector quantity, length is also a vector quantity. And we are going to use this DL vector again in this chapter when we are going to talk about force acting on a current carrying conductor kept in a magnetic field. Over there we are going to write, if you remember, over there we are going to write IDL cross B. Got it? And that's how we get BIL sine theta. These things have a pattern, my dear friends. So do not get worried. Understand few things in one sitting. After that, try to remember as much as possible and then quickly solve PYQs. So every day have a habit of solving now, because we have got only 6 or 7 days left for NEET exam. I would suggest you to solve at least 15 to 20 questions of PYQs from 10 questions from NEET, 10 questions from mains. That's it. Why? Because I want you to revise lots of things again and again. Please don't do this that now you are studying mechanics for 2 days. That will not work. Instead, for 2 days, complete the entire chapter of physics twice. It might look like that you would want to skip rotational motion, then skip it for a moment, but revise often, right? Moving on, now we have got next is actually again the use of Biot-Savart's law. You don't have to derive it. Please remember this formula. Again, it is similar to electrostatics. We learn Ampere's law, just like in electrostatics we have learned Gauss law. So this is the formula for magnetic field due to a current carrying straight wire. Sine alpha plus sine beta, these are the angles, and again you have got infinite length, you have got semi-infinite length. If any student has just now joined, let me tell you, I have explained this thing in electrostatics, so I am skipping right now. Okay, it is similar. Now this is where you can save a lot of time. For a square, magnetic field will be 2 root 2 mu naught I upon pi L, where L is the length. For a regular hexagon, you have got root 3 mu naught I upon pi L. So that is 2 root 2, this is root 3, and other other than this numeral value, the value is same, that is mu naught I upon pi into L. Mu naught I upon pi into L, numeral value is 2 root 2, numeral value is root 3. Similarly, numeral value over here is mu naught, sorry, over here you will have to remember it, that is mu naught Ni divided by pi L tan pi by n sin pi by n. This is slightly different, this is slightly out of the box, but this is for a general polygon. A general polygon. So what you can do is, if you want to save time, you can remember this formula directly and then you can use it. Clear? For example, as for a square, my dear friends, you will have n equals to 4, right? You have got n equals to 4, so just substitute the value. This is going to be 1, sin pi by 4 will be 1 by root 2, right? And my dear friends, this is going to be 4. So you have got 4 and you have got root 2. Got it? So that becomes, over there, that becomes 2 root 2, right? So this is how you can do it. Instead of remembering, you will say, sir, how can I remember for square, hexagon, we can have a triangle, we can have different things. So instead of this, simply remember for any polygon at the center. Clear? Everything is sorted. Be quick, let me know. And then if you want to have for triangle, again you can use it. That would become tan 60, and that this would become sin 60, and the n will be equals to 3, and then again use it. By the way, this is slightly different. The next thing is, sir, if I start now, can I get in CUT? John, right now we are not talking about CUT, buddy. We are talking about NEET. So let's stick to this. Okay. Come on. Now let's move on. So hopefully this is also clear. See, this formula, we have derived this formula using this only. Whereas in the second case, something is really important. If the total length L is bent as an equilateral triangle and each side has length L by 3, then that means we have got a total length L and then we have bent it into a triangle. Then it would become 27 by 2 times mu naught I upon pi into L. This is going to be magnetic field. All right, clear? Again, same formula, and if I'll ask you where will we have maximum magnetic field, answer will also be same, x equals to r by root 2. Got it? So same magnetic field formula, and then also use a concept of magnetic moment. Magnetic moment is NIA. Over here they have not written N, it is NIA, where capital N is the number of turns. And then you can also write down mu naught upon 4 pi 2m divided by x square plus r square whole raised to the power 3 by 2. Done and dusted? Clear? Can we move on? I have told you that when I am going to explain magnetism, I will be a little quick, because all of these things we have already completed in electric charges. This is what I was trying to say. And by the way, please remember the directions also when you are going to discuss the current flowing into a circular coil or into a solenoid. It will behave as a magnet and the sides will behave as a north pole or a south pole, depending on whether the current is flowing in anti-clockwise direction or clockwise. So if anti-clockwise, we have got north, if clockwise, we have got south pole. Clear? Done? Next is my dear friends, Ampere circuital law. Everyone knows Ampere circuital law. The line integral of B dot dl will be equals to mu naught times of net current, right? Or I enclosed. So if you have got a loop like this, and from this loop you have got different wires, something like this. Let's say this is I1, this is I2, this is I3. Then net current will be I1 minus I2 plus I3. Just take any direction as positive, the another direction will automatically become negative. And then the next thing is, just like application of Gauss law, we will have application of Ampere circuital law. Yes, this is very easy, that is why we are also moving quick. Hollow cylindrical pipe, that means there is nothing inside the pipe. So current will only flow from the periphery, from the surface. So total current is I, so magnetic field outside will be mu naught I upon 2 pi r, and magnetic field inside will be 0 because there is no current inside the surface. So again this is very similar, on surface and outside the surface, clear? And this is the graph also for you. So everything is over here. Done? Moving on. For solid cylinder, again it will be similar to what we have run, at least the concept is similar. Outside we don't have any problem, mu naught I upon 2 pi r, right? So on surface also we don't have any problem. When we are going to talk about inside, we must find out the current density first. So for finding out the current density will be I divided by total area, that is pi r square. Sorry, pi r square. So if you want to find out I, we are going to write down I into pi r square multiplied by pi into small r square. So that is how you are going to get to the magnetic field of inside point. Alright, clear? Now my dear friends, this is also very important. Please note this. Sometimes students skip annular pipe when they are talking about Ampere's law. Right? Got it? In annular pipe, again you are going to use the same thing. For outside point, we don't have any doubt, because for outside point, if someone is saying that total current is I, I'm going to simply write mu naught I upon 2 pi r. I don't have any doubt, because when I'm going to draw an Ampere loop for an outside point, the total enclosed current will be I. I don't have any doubt. But when you are going to talk about an inside point, also inside point, if someone is saying that R is actually even smaller than R1, where have they put this? If R is even smaller than R1, then also I don't have any doubt, because then magnetic field will become 0, because there is no current inside that loop, enclosed in that loop. Got it? We have got a problem when they are saying that radius is actually in between of R1 and R2. Then again we will have to do the same thing. We will say that the total current, the current density is total current divided by total area. My dear friends, total area is pi R2 square minus R1 square. In this area we have got total current multiplied by, now we are talking about this loop. Just let me tell you, this is the loop, this is the area in which we are discussing our current. So this area is pi r square minus r1 square. So this is going to be the enclosed current. Everything is correct? Write down in the chat box, be quick, and this is how you are going to get magnetic field. Be quick, let me know in the chat box if you have any doubt. Right? So current density is a particular topic which is again very easy, and if they want to increase a level by a bit, they can use the concept of current density, right? So now let's move on. Hopefully everything is clear from annular pipe, and now let's move to solenoid. My dear friends, usually all of you only remember the formula of solenoid as mu naught into Ni. Please also remember this formula. They might ask something from here. If you are not remembering this, at least remember that at the end points formula is mu naught Ni upon 2, right? Generally the formula is mu naught Ni upon 2 cos theta 1 plus cos theta 2. For at center, magnetic field is at center or inside, magnetic field is mu naught Ni, and outside it is 0. Also remember that outside the solenoid it is 0. Along the axis it will be mu naught Ni. That means at this particular point it will be 0. Now comes the second part of this topic, of this chapter, that is motion of charged particle, which is very easy. But again, you can save a lot of time in remembering these things. Please again remember, wherever you have got this under root 2 mke mv, in how many chapters we have got this? in this chapter and in modern physics, right? So wherever you have got this under root 2m into ke, either they are going to talk about charge or potential. So either remember the ratio of the charge and mass, or remember this under root v formula from modern physics, right? I'm just giving you a hint. So radius is obviously momentum divided by QB, mv divided by QB. Using this momentum formula, you can find out time period. Time period is 2 pi m divided by QB. It is very important to note, it does not depends upon radius, it does not depends upon velocity. This is a way of saying that T is independent of velocity, and that is speed of the charged particle, and T is also independent of the radius of the charged particle. Moving on, if this is what I was saying, that if it is possible for you, remember the ratio for proton, deuteron and alpha particle. Proton, deuteron and alpha particle radius, simply it is 1:2:2, right? Obviously proton has the least radius, and deuteron and alpha particle has the same radius. After this lecture, I'll try that I can get these PDFs uploaded on all of the descriptions of this YouTube videos, right, of this live lecture. If all particles are projected with same momentum, my dear friends, please remember that if it is thrown with same momentum in same magnetic field, then radius depends inversely on charge. That means for proton, deuteron and alpha particle, it would be 2:2:1. If let's suppose you're not able to remember it, or if it looks like that it is not so much important, you can skip it also, because formula is very easy. Please try to understand what to remember and what not to remember, because you have got limited capacity to remember things. So it's not like that if I have said keep remember this, so you must remember this also. Hopefully you are understanding what I am trying to say. Remember those things which will save a lot of time for you, especially the general formula. And if you remember the general formula, then you can actually find out any specific formula in exam using that general formula. Now let's suppose even if you have got doubt in that general formula in exam, then that will cost a lot of time to you, because then you will think, you will try to derive, you will waste some time. Do not do that. Clear? So I'm not at all saying that if I have said remember this, or I've got a formula over here, I've got ratio over here, then you must remember it. Clear? So moving on. Similarly, let's talk about helical path. This is also very easy. Now, in the previous case, particle was thrown perpendicularly to the magnetic field. Now we are throwing particle at a particular angle to the magnetic field. So now the radius of curvature will become r mv sine theta divided by QE. Time period does not depends upon speed, so time period will still remain 2 pi m divided by QB, and something that is called as pitch. If you don't know what pitch is, my dear friends, let's suppose this is the direction of magnetic field, and this is the direction in which we have thrown the charged particle. So the charged particle has two velocities, one is perpendicular velocity, one is horizontal velocity. My dear friends, there will be no change in this velocity which is parallel to magnetic field, right, because there will be no force acting because of this velocity. Because of this velocity, it will actually move in circular motion, and it will constantly make the particle to move in x direction, and as a result particle will move something like this. This is known as pitch. So pitch is simply velocity in x direction multiplied by one time period. So that is how you are going to get it, right? Let me know. Now the important thing is to remember this formula, basic formula, to remember this formula, and for pitch you can quickly write it down. There is no doubt. Clear? Quickly let me know in the chat box. Done? Can we move on to the next topic? Sorted? Come on. Now we have got force on a current carrying conductor in magnetic field, right? This is again very important because they can ask a question from here, and I have told you, please remember this is I times L effective times B. You can remember it something like this also. You can remember it for a small part of wire, it can be remembered as I times DL cross B. DL cross B. All right. And if let's suppose this is perpendicular to magnetic field, then it will be simply BIL. Why we are talking about BIL effective? Because see, the wire is something like this. Let's suppose wire length is 100 meter, but we are not going to talk about the length of the wire. We are going to talk about DL vector. This is DL vector. This is DL vector. Got it? So let's suppose if you have got a wire something like this in this magnetic field. So in this case, the integral of DL will be 0, right? Integral of DL will be 0, correct? So integral of DL will be 0, that means force will be 0, and that is what we say, net force acting on a closed loop is 0. Net force acting on a closed loop is 0. But torque will act. Torque might act, net force will be 0. So please remember this thing, and this is what they have written. For a closed loop in uniform field, L effective is 0, so force is also 0. But we know that torque might act on this thing. Now the next is, my dear friends, force between two parallel current carrying wires. Understand this thing, that if the current is flowing in the same direction, in the like direction, then it repels. So if current flows in the same direction, I'm sorry, if it is like, then it attracts. It is opposite, right? Opposite to what we usually say, that like repels. Over here it is different. Over here, like direction attracts, opposite direction repels. And they have not written force. Let me write it for you. The force experienced by a particular wire will be, my dear friends, mu naught upon 4 pi 2I1 I2 divided by separation is R, and multiplied by length. So let's suppose you are talking about, sir, find me F12. So I'm going to write F12 is equals to, let's suppose the length of this wire is L1. So let's multiply L1 over here. So we are going to get F12 divided by L1. We are going to call it as force per unit length. And by the way, it follows Newton's third law. So F12 will be equals to negative times of F21. So it would be force per unit length, and it will be same, and the formula is mu naught upon 4 pi 2I1 I2 upon R. Got it? Done? Now we are starting next topic, but in 5 minutes. In 5 minutes, then we are starting. All right. So wait for 5 minutes, and then we'll start again from this topic only. All right. So let's begin. Let's resume. So next is Lorentz force. We don't have a Lorentz force written over here, no problem. Lorentz force is, my dear friends, F equals to QE plus QV cross B, where QV cross B is the magnetic force. This is called as Lorentz force. Now in this, there is also one more specific case, which is the case for velocity selector, and again in NEET 2025 they have asked a question from velocity selector, right? So in velocity selector, what usually happens is, let's suppose that you have got a charged particle Q. Let's suppose you have got a positive charge particle Q. And also let me tell you all the other cases. If you have got a negative charge particle, like for example as electron, and magnetic field is something like this, directed into the board, directed into the board, then this particle will experience a magnetic force in the upward direction. Correct? This particle will experience a magnetic force in the downward direction. So this is magnetic force and this is magnetic force. That means if only magnetic field is going to, we are going to only apply the magnetic field, then the path of this particle will be something like this, and it will be a circular motion or whatever, that depends on the region where magnetic field is there, right? It will have a circular path if there is only magnetic field in entire region, correct? And this particle will have a path something like this. But let's suppose we want this particle to go undeviated. Let's suppose we want this particle to go undeviated. In that case, we'll have to apply another force on it that should balance this magnetic force, and that will be electrostatics force. That means F into E. Similarly, over here, we'll have to apply electric field and electric force like this, right? And for doing so, electric field will be applied in this direction. For doing so, electric field will be applied in this direction. I'm sorry. For doing so, electric field will be applied in this direction only. Correct? Because for a negative charge, force acts in opposite direction to electric field. So QE equals to QV cross B. So Q and Q gets cancelled out. So velocity comes out to be E by B. Please remember, they have asked the same question from this topic in NEET 2025. Now moving on, my dear friends, now you have got moving coil galvanometer. Remember the formula for current sensitivity and voltage sensitivity. Very important. Remember the formula. They can ask a question from here that on which factors current sensitivity depends. So it depends upon the total number of turns. It depends upon the area, magnetic field, and constant. This K is galvanometer constant, right? And then voltage sensitivity is simply current sensitivity divided by IR. That is NAB divided by KR. So remember this. And then the next thing is magnetic dipole. Yes, exactly. Velocity selector. Correct. All right. Clear? Next is, my dear friends, magnetic dipole. We have remembered one formula for magnetic dipole, that is NIA. Another formula is pole strength multiplied by length. Also remember, if you are going to actually direction is from south pole to north pole, unit is all clear. Remember this, if you are going to bend a magnet, if you are going to bend a bar magnet, something like this, at an angle of theta, then this effective length will change. This effective length is going to change and it will become L dash. And remember the general formula of L dash, because you will waste a lot of time in solving it. By the way, it will not take complex method. Normal geometry will, using normal geometry, you can solve it in normal trigonometry. But remember it is sine theta by 2 divided by theta by 2. Obviously, theta is in radians, right? Next thing is finding out the new magnetic moment. So new magnetic moment will be m sine theta by 2 divided by theta by 2. Again, this is very important. It will save your time. Moving on, my dear friends. Next is resultant dipole moment, like this. You might have seen lots of questions in which they say this is going to be from south to north m, from south to north m, that means m square plus m square 2m1 m2, and let's suppose this angle is 60 degree. So that means 2m m square cos 60 is 1 by 2, and you can find out net magnetic moment. Clear? Be quick. If you are going to cut a bar magnet, and if you are going to cut a bar magnet lengthwise, that means transverse in a transverse direction, that means length will become L by 2 and L by 2. So pole strength remains same, but length becomes half, so magnetic moment will become half. If you are going to cut it in a horizontal manner, then length will remain same, but pole strength will become half. So you have to remember this, then pole strength becomes half. That means length becomes same and length remains same and pole strength reduced to half. Again, magnetic moment will become half. Right? Okay. Moving on to the next topic, that is magnetic permeability. This is the next part of this chapter, which is again very important, and if you'll ask me, if you have time, read NCERT for this particular section. If you don't have time, watch this recording. Most of the things will get cleared, right? Magnetic permeability, you're going to talk about two things. One is absolute permeability of free space, that is mu naught, everyone remembers this, and one is relative permeability of any medium, which is absolute permeability of a medium divided by absolute permeability of free space. So this formula is very simple and very common. We always talk about relative formulas like this. Relative permittivity was also written in the similar manner, and this also, like for example, as for any medium, absolute permeability is relative permeability divided by mu naught. Sorry, multiplied by mu naught. And then you have got intensity of magnetizing field. Intensity of magnetizing field is given by H vector, and it is written by B external divided by mu naught. These formulas are only for your revision. I am not explaining them. So please complete intensity of magnetization and magnetization field also, right? Capital M, that is induced dipole moment per unit volume. Clear? Moving on, because using all of these things, we are going to explain different types of materials, that is paramagnetic, diamagnetic and ferromagnetic. And the next one is magnetic susceptibility, right? If any one of you have any doubt in these terms, I can explain it if you are going to ask me. Else I am moving on. This is also very important, that is relation between relative permeability and magnetic susceptibility, that is mu r equals to 1 plus magnetic susceptibility, right? And relation between B, M and H. So I think this is all good. Using this relation, you can identify which material will have mu r greater than 1 or less than 1. Mu r will be always greater than 0, right? Now you have got magnetic materials, like for example as diamagnetic materials. Now I'll try to explain the other terms also. For example, as if someone is saying that mu r for this, is less than 1, what do you mean by this? We mean to say that absolute permeability of this particular material will be less than mu naught. That means when you are going to keep this material in a magnetizing field, it will get demagnetized. That means its magnetic dipoles will get aligned in the opposite direction to the magnetizing field, right? So that's why its psi is negative. See, they are talking about superconductors. So superconductors are very exotic materials. That's why mu r is equals to 0. They are exotic materials. All the other materials, 99% of the materials of diamagnetic also, mu r is not going to be 0. It will be less than 1. It will be less than 1, but not 0. Got it? Clear? Done? Magnetic permeability tells us how easily a magnetic field. That's absolutely correct. Absolutely correct. Right. So this is the important thing. Magnetic susceptibility will be less than 1, greater than -1. Relative permeability will be less than 1 or greater than or equal to 0. It will be equal to 0 for superconductors. Superconductors are those materials in which inside the superconductors magnetic field becomes exactly 0, and mu will be obviously less than mu naught. The next important thing is to remember these examples, that is copper, silver, NaCl, H2O and gold. Got it? And then individual atoms do not possess permanent magnetic moment. This is also an important point. Do not forget this. And no effect of temperature on magnetization. This is also very, very important. Clear? Done? Any more doubts? Next are paramagnetic materials. So paramagnetic materials, they do get magnetized, but they get weakly magnetized or weakly attracted towards the magnet. Weakly magnetized can be also, we can also say it in one more way, that it is weakly attracted to the magnets, right? Diamagnetic materials are weakly repelled. So the effect is a weak effect. The effect is not a strong effect. So diamagnetic material gets repelled or they get magnetized in opposite direction, right? So they get magnetized in the opposite direction, and the paramagnetic material, they get magnetized in the same direction, but there is a weak magnetization. So mu r will be greater than 1, but it will not have large values, right? So mu r is greater than 1, but it does not have a large value, that is 1 plus epsilon, that is it is a small positive value. So obviously if mu r is greater than 1, mu is written as mu upon mu naught, so it would be greater than 1. That means mu is greater than mu naught. So this is what I was trying to say, that these terms are important. Magnetic susceptibility is important. Yes, plus please mind one thing, that these things will be important if they will give you any numerical. If they will ask you any numerical, you will have to use these formulas. So please be prepared for that. Next is, my dear friends, Curie's law. Magnetization of paramagnetic material is inversely proportional to absolute temperature. So you can also draw a graph that magnetic susceptibility is inversely proportional to temperature, where C is Curie's constant. Moving on, the next one is ferromagnetic substances. It gets strongly attracted by a magnet. Examples are iron, cobalt, nickel, cadmium and iron oxide, right? Individual atoms do not possess, in this case individual atoms do possess permanent magnetic moment. Individual atoms of paramagnetic also possesses magnetic moment, but the difference is that over here we have got some domains. In these domains, the dipoles are in same direction. So it is actually relatively easier to actually to align these domains, to align these dipoles in one particular direction. It is relatively easier. This is the difference between ferromagnetic and paramagnetic, right? So due to exchange and magnetic moments of neighboring atoms tends to align due to force called exchange coupling. This is not that important about exchange coupling. Due to exchange coupling, atoms form domains inside which magnetic moments are aligned in the same direction. So over here magnetic susceptibility is far greater than 1, mu r is far greater than 1 and mu is far greater than mu naught. Clear? Any more doubts, my dear friends? I have given you examples. We have talked about all of these terms and their relation with one another. Clear? Sorted? Be quick. Let me know. Next is, my dear friends, our chapter electromagnetic induction. In electromagnetic induction, please remember the formula for magnetic flux, just like electric flux, nothing new. It is a scalar quantity, SI unit is Weber, right? You remember the dimensional formula of magnetic flux, and then comes Faraday's law. In Faraday's law, the first law is that induced EMF is minus d phi by dt, minus d phi by dt, right? Or the total induced EMF will be n times of d phi by dt through one term, and then this thing can be written as minus n and dBA cos theta by dt. So either you can change magnetic field, you can change area, and you can change angle, and if you are going to change any one of these or more than one thing, there will be an induced EMF and then there will be induced current. So please remember the average value of induced EMF will be del phi by del t, and the instantaneous value will be d phi by dt. Correct? Done? Any doubt? Sorted? And induced current will be induced EMF divided by resistance. Induced EMF divided by resistance, and same formula over here as well. So these are basic formulas, you don't have to worry about them. Even if you have studied EMI for one day, you must be knowing these formula. Next part is inductance. Please note that I have not explained the concepts between these of the EMI. I am only talking about formula in this case, and then we are going to talk about motional EMF case later on. So inductance is a scalar quantity, SI unit is Henry, dimension formula is this. Inductance is going to be two types of self inductance and mutual inductance, right? And we know that flux is actually directly proportional to current. So flux can be written as L into I, or L can be written as phi by I. That means correct, clear? So they used to write E equals to minus d phi by dt. So from now on we can write down E equals to minus L di by dt. So remember this formula also, L di by dt. From this, let me also explain one thing to you. I think we don't have a slide for that, so I'll use it. Let's suppose that you have got a wire like this whose self inductance is L, and then current I is flowing. So we can have three cases in this. Let's suppose that current is constant. In this case, let's suppose current is constant, current is increasing, current is decreasing. Then in this case, my dear friends, if current is constant, then this inductor will behave as a clean wire. There will be no change. Why? Because just now we have written that E, magnitude of E is at least L di by dt. Now if current is constant, this will become 0, right? And if let's suppose current is increasing, and it is increasing at a rate of di by dt is given as, let's suppose it is given as alpha, right, or whatever, 2 ampere per second, whatever. Then in this case, there we are going to assume an imaginary battery whose EMF is L di by dt. And please remember, I have removed that negative sign because that negative sign only explains the Lenz's law. Clear? Any doubts in this? And again, if let's suppose this is decreasing, then this will be this battery will be something like this, and again E will be L di by dt. That's it, my dear friends. Hopefully everything is clear. Other than this, please remember L can be written as phi divided by I. And now we can talk about self-inductance of a solenoid. Everything is clear, right? Please remember these three cases. That's it from the inductor part. And then we are going to talk about self-inductance of a solenoid. So self-inductance of a solenoid will be phi divided by I. We know what phi is. Let's see it. This is a self-inductance of a long solenoid. Magnetic field is mu naught Ni divided by L. Please remember this thing, that wherever they are going to talk about small n, it is going to be capital N divided by L. So capital N will be small n times L. So instead of small n, they have written capital N divided by L. Phi will be mu naught. Magnetic flux is, please remember, magnetic flux is magnetic field multiplied by area. So this is magnetic field, mu naught Ni divided by L. So mu naught Ni and multiplied by area for magnetic flux. So magnetic flux is done. Now we know that inductance is actually equals to phi divided by I. So let's just divide this by I. So I and I will get cancelled out, and self-inductance will be mu naught N square A divided by L. Let me know in the chat box if you have any doubt. Clear? Done? Any more doubts? Be quick. All right. And this is the formula that I want you to remember in terms of capital N, and this is the formula in terms of small n. Please remember, this A times L can be also written as volume, right? So we can also find out inductance per unit volume, but fine, you remember inductance till here. And then you have got energy stored in the inductor, that is half Li square. In capacitor it was half Cv square, in inductor it is half Li square, right? Magnetic energy stored per unit volume will be total energy divided by total volume, which is B square by 2 mu naught. My dear friends, we are going to use it in electromagnetic waves also. Got it? Done? Everything's clear? And then series and parallel combination of inductors. So it is very similar to what you have seen in resistances. L equivalent will be L1 plus L2, and over here L equivalent will be 1 upon L equivalent will be 1 upon L1 plus 1 upon L2. Formula is same, exactly same. Any doubts, my dear friends, still here? Because after this you have got mutual inductance left in this chapter. Mutual inductance is similar to self-inductance. Self-inductance was, let's suppose this is a solenoid, and if I am going to change the current flowing in this solenoid, then because of that there will be an induced current. Mutual inductance is that change in current in one coil will produce an induced current in another coil. So mutual inductance is given as phi is direct, I'll write it down for you. This is flux linked in secondary coil is directly proportional to current flowing in the primary coil. And then removing the proportionality sign, capital M will be the mutual inductance. M is called as the mutual inductance of the coils. Again, instead of d phi by dt, we can write down M di by dt. Similar formula, my dear friend, just like self-inductance. Please understand, all of these things are easy. The difficult part is mutual inductance of two long coaxial solenoids. So let's complete that as well. So it is going to be, you have got phi flux on 1 due to 2. That means current is flowing in second coil. So this is how you are going to write down the formula. If you have any doubt in this, let me draw a diagram for you. See, we have got a solenoid something like this. This is one solenoid and this is another solenoid. This is how the diagram looks like. But if I draw a cross section diagram, then you will get it even better. See, let's suppose that this is the primary coil in which we have got current, right? And this is the secondary coil. Right? And current is flowing in, let's suppose, in this yellow wire. Current I is flowing in this yellow wire, right? So magnetic flux will be linked from this part. So we can write down this magnetic flux linked, and it will be equals to magnetic field due to wire, due to solenoid 1 multiplied by area of this thing. So let's suppose this is R1, this bigger one is R2. So we are going to write pi into R1 square, and let's suppose total number of turns is N1. So we are going to write N1 and so on, right? Clear? So hopefully you are able to understand how we are going to write. And now phi divided by current, you are going to use current from here. Phi divided by current will give me mutual inductance, and this is the formula. All right. Also remember the formula which relates mutual inductance and self-inductance, that is K multiplied by under root of L1 times L2, where K is known as coupling constant or coupling coefficient, right? Coefficient of coupling, where let's suppose if it is a perfect coupling is a case something like this. This is a perfect coupling case, right? So for a perfect coupling, K will be 1. What about this? Let's suppose I have got a case like this. This is one coil, and then we have got another coil like this. The coupling constant for this one will be 0. Coupling coefficient for this one will be 0. Why? Because almost no magnetic field lines are getting linked with one another, right? One of them can be primary, another can be secondary. So coupling constant will always be between 1, that is maximum, to minimum, that is 0. And the relation is this. So this is the maximum case, maximum K equals to 1, right? It has got, let's suppose, L1 it has got, let's suppose, L2 as self-inductance. So we can also directly find out mutual inductance using this. Is everything clear? Quickly write down in the chat box. For imperfect coupling, K will be equals to 0. Hopefully, my dear friends, you have no doubt. Alright. Now you have got dynamic motion, motional EMF of a translatory motion. That means we have got, let's suppose we have got a frame like this. And we have got magnetic field over here. It has got certain velocity v, magnetic field is b, its length is L. So induced EMF comes out to be BVL. And the direction of induced EMF is like this. And by the way, how you are going to find out direction of induced EMF? Using right hand thumb rule. Magnetic field in this direction, motion in this direction, so induced current will be upward. Got it? Clear? Any more doubts? Right, so it's going to be BVL. Let's suppose that you have got rod, but it is moving in this direction. You have got a rod, but it is moving in this direction, V. Then you will have two velocities. One velocity will be V sine theta and another velocity will be V cos theta. So in this case, E will be BL into V perpendicular, that is V sine theta. Right? If you have got a loop like this, then please remember we are going to write BLV, but instead of V, don't write 2R. I mean, so sorry, don't write this as pi R. Write L effective. So L effective will be 2R. So L effective will be 2R. So we are going to write B into 2R into V. Hopefully everything is clear. Similarly for this one, this is going to be L effective. Is everything clear? Be quick. Let me know in the chat box. Sorted? So always remember that we are going to write it as L effective. Any more problem? You can ask if you have any doubt. Done? What if we have got a rotating rod? Let's also write for rotating rod. If let's suppose it is rotating with angular velocity omega, length is L, and it is in magnetic field B. So we are going to write down EMF as B omega L square divided by 2. Clear? B omega L square divided by 2. Now, my dear friends, let's start alternating current. Right? Let's see alternating current. In alternating current, the first thing that you must remember is normal basic IRMS and VRMS values. My dear friends, peak value, if peak values are V0 and I0, then IRMS values will be V0 divided by root 2 and I0 divided by root 2. This is all clear. Also, please remember that if they are going to talk about sum of two alternating voltage source, then use principle of superposition that I have explained to you in SHM, and I have also explained that you can use that in alternating current in every chapter of waves. Hopefully you are understanding what I am trying to say. Let's suppose that they are saying that V is actually equals to V1 sine omega t plus V2 cos omega t. So first of all, rewrite this thing as one function. I'm trying to say that this is, if this is in sine, then write this thing also in sine. And then, so if we'll write it down, we'll write sine omega t and we'll write V2 sine omega t plus 90 degree. Am I right? Sine A cos B, cos A sine B. Right? Now this is A1, this is amplitude A1, this is amplitude A2. And this is theta and this is phi. So use A net equals to under root of A1 square plus A2 square plus 2A1 A2 cos phi. So my dear friends, cos phi in this will be 90 degree, phase difference is 90 degrees, so this becomes 0. So this becomes under root of V1 square plus V2 square. That is V net. Now please remember, this is only applicable when we have got a sine, when we have got a 90 degree over here, and even before that please try to make both of them as sine. Any more doubts? Quick, let me know in the chat box. Done? So remember this. The next thing is about the average value. The average value is defined only for half cycle, because for a full cycle sine and cos both will give 0 as their average values, right? So please remember, it is only defined for half value. So for half value it is 2 I naught divided by pi and 2 V naught divided by pi. So this is also very, very important. Clear? My dear friends, everything is sorted. Can I move on? Next is, my dear friends, single component circuits. So if you have got single component circuit, like for example as if you have got purely resistive circuit, if we have got purely resistive or purely, let me do one thing, let me give you a quick revision by simply telling you a combined circuit. That means an LCR circuit. Please see, in 5 minutes or in 5 to 10 minutes, I am going to revise complete alternating current for you. Please remember that if you have got an LCR circuit, something like this, let's suppose, and this is V naught sine omega t, and let's suppose even if you don't know it, we don't have any problem, right? Let's say that it is given. We have got L, we have got capacitors, and we have got resistance, right? Sorry, L. So what I am trying to say is that always remember that across inductor voltage leads, across inductor voltage leads. So when you are going to draw a diagram and across this voltage lags, and this has voltage and current have 0 phase difference, correct? So when you are going to draw a diagram, phasor diagram, this is going to be IR, voltage drop across resistance, this is going to be voltage drop across inductor, this is going to be voltage drop across capacitor, VC, VR, VL, and this is VI. Now what I am trying to say is VR. What I am trying to say is that if you have got only inductor, that means voltage will lead, current will lag by 90 degree, voltage will lead. If you have got only resistance, voltage and current will have same phase. If you have got capacitor, voltage will lag, current will lead. Got it? Voltage will lag, current will lead. So what I am trying to say is that in this case, similarly you can draw a diagram for XC, XL and R. Now first of all, write down the formula for impedance. Formula for impedance is XL minus XC whole square plus R square. Now let's suppose somebody wants us to write down the equation of current over here, right? So equation of current will be written as I equals to, across this one, it will be XL multiplied by V. We can write current equals to V times L. Please remember this. This is sorry. Just a second, my dear friends. VL can be written as I times XL. VC can be written as I times XC. VR can be written as I times R. Got it? Right? So if you want to find out I, you can write down VL divided by XL. If you want to write down I, you can write down VC divided by XC. If you want to write down I, you can write down VR divided by R. Got it? And you can find out impedance using this formula. Let me know if you have any doubt. And then let's suppose if XL is greater than XC, then it will be an inductive circuit. If XC is greater than XL, then it would be a capacitive circuit. And then if let's say XL is equals to XC, then it will be a case for resonance. And if XL is equals to XC, then Z will become equals to R, and we are going to call it as a purely resistive circuit. Is everything clear? Any more doubts? Be quick. Let me know in the chat box. If you want to find out the peak value of current, write down peak value of voltage divided by Z. If you want to find out RMS value of current, write down VRMS and write down Z. If you want to write down the equation of current, then first find out the phase difference. For finding out the phase difference, draw an impedance triangle. So let's assume that this is XL minus XC. This is R. This is Z. So this is going to be phi that I was talking about. So tan phi will be equals to, or let me write it down, my dear friends, as tan alpha for now. It would be mod of XL minus XC. Why I am writing it down mod? Because I really don't know whether XL is greater or XC is greater. And even after finding that out, I just want to find out the value of alpha. If XL is greater, then I can simply say that it's an inductive circuit divided by R. This is going to be tan phi. And similarly cos tan alpha. Similarly cos alpha will be R divided by Z. Be quick. Any more doubts? Clear? Be quick. Now, next thing is resonance. So for resonance, just now I have told you that XL will be equals to XC. That means omega L will be equals to 1 upon omega C. That means omega will be equals to 1 upon under root LC. So remember this formula, and remember that resonance frequency will be, this is omega, resonance frequency will be 1 upon 2 pi under root L by C. In resonance frequency or at resonance frequency, inductive circuit is cancelled by capacitive circuit, and we have got a purely resistive circuit. So that means our current becomes maximum. Why? Because current was equals to V divided by Z. And by the way, let's suppose we are talking about I naught, so it is V naught divided by Z. If you are talking about IRMS, it is VRMS divided by Z. Any more doubt? Clear? The graph of resonance circuit looks something like this. Please see. This is how the resonance circuit looks like. This region has angular frequency less than resonance frequency. This region has angular frequency greater than resonance frequency. And at this point, we have got resonance frequency, and you can see current is maximum at this point. Right? Alright. Next is, if let's suppose they are saying that angular frequency is less than resonance frequency, that means XC is greater than XL, that means current leads. So in this region, current leads. If omega is greater than omega R, then in this region, current lags and voltage leads. And similarly, you can say that if current lags, that means XL is greater than XC. And if current leads, then XC is greater than XL. Correct? And then the last formula for resonance, and that is quality factor. Please remember, this is XL divided by R. Quality factor or Q factor is written as XL divided by R. This is known as quality factor. Any more doubts in this one? Be quick. Clear? Can we move on? Another formula for resonance is sharpness of resonance. Sharpness of resonance can be written as omega R divided by 2 times of delta omega. Omega R is angular frequency, and 2 times of delta omega is actually known as bandwidth. And I'll tell you what bandwidth means. Bandwidth basically means this thing. We have got 2 values over here of omega. Let's say this is omega 1 and let's say this is omega 2. For both of these omega 1 and omega 2, we are getting current as I naught divided by root 2. That is I RMS. So this is known as delta omega. So this whole thing, that means 2 times of delta omega, 2 times of delta omega is actually known as bandwidth. So let me again tell you, this formula of omega r divided by 2 times of delta omega will tell us how sharp the resonance graph is, right? So this is known as sharpness of resonance. Sharper or narrower the resonance is. And then the next formula is very important, that is power in AC circuit. Average power is written as VRMS into IRMS into cos phi. Let me tell you, average power is written as VRMS into IRMS into cos phi. My dear friends, this is known as apparent power. And this cos phi is known as power factor. And again, cos phi is nothing but R by Z. R by Z. So if you have got a purely resistive circuit, then phi is 0, cos phi is 1, and then you have got maximum power delivered. Which part? Which part? I'll explain it again. Which part? Just tell me the name of the topic, I'll explain it again. Be quick. Clear? For purely inductive or purely capacitive, for purely inductive and purely capacitive, phi will be 0. If you are talking about this graph, let me tell you again. Hold on. Okay, no problem. I'll explain it again. Let's remove all of these things. This is angular, this is resonance frequency, right? What I'm trying to say is then on either sides, we are going to have frequencies omega 1 and omega 2 such that my dear friend, that on these frequencies omega 1 and omega 2, the value of current will be 1 by root 2 times of peak value. Got it? 1 by root 2 times of peak value. So I am saying this difference is known as delta A. Sorry, delta omega. So this will be also delta omega. So the difference between omega 1 and omega 2 is known as bandwidth. This is known as bandwidth. So bandwidth divided by omega r is given as sharpness of resonance. Now it's fine. Clear? Can we move on? Done? Next is, if you are going to talk about purely inductive or purely capacitive circuit, in that case, cos phi will become 0, angle will be 90 degree. Obviously, right, because for purely inductive and capacitive, either the current lags or current lags, and it lags by 90 degree. Current leads or current lags, or you can talk about voltage. So that means phi will be 90 degree. That means no power is dissipated even though current is flowing, and this current is known as wattless current. This current is known as wattless current. Right, so LCR circuit has phi non-zero, and that's why power is VRMS into IRMS into cos phi. And at resonance, again cos phi becomes maximum. That means at resonance, again the value of current becomes also becomes maximum, and power also becomes maximum, because resonance is nothing but it is a purely resistive circuit. The only difference is that in resonance we have got inductor, we have got capacitor, but they cancel out each other. Got it? They cancel out each other. Any more doubts? Clear? Can we move on? Last topic of alternating current, that is transformers. Please remember it. This is a very easy thing. Transformers are either used for stepping up a voltage or step down a voltage, right? So that current can be transmitted from power stations to to residential places or to any destination. So equations that are given in transformer is something like this, that Vs divided by Vp, that means voltage on secondary coil divided by primary, is equals to ratio of number of turns on secondary divided by primary. The only thing is that the ratio of current is reverse, it is inverse, right? And the reason is we use two things. First is that there is no flux leakage, no loss, and for power also there is no loss. So P1 V1, I'm so sorry. So P1 or P is equals to PS. That means Vp times Ip is equals to Vs times Is. So Vp upon Vs is equals to Is upon Ip. This is the case, my dear friends, right? And then for formula of efficiency is simple, output power divided by input power times 100, you will get it in percentage, and these are some of the terms. Any more doubts? Clear? Can we move on? Next is, my dear friends, electromagnetic waves. Electromagnetic waves, remember the definition, and there are only 4 or 5 formulas in this entire chapter. Other than that, the facts about electromagnetic waves are the most important thing. That includes properties, how they are produced, their uses, right, and the range of their wavelength and frequency. So 4 things: properties, their uses, wavelength range and frequency range. Other than that, remember some of the basic things. All electromagnetic waves in vacuum travel with this speed, that is 3 into 10 to the power 8 meter per second. These are oscillating and magnetic fields which are mutually perpendicular to each other, but they don't have any phase difference. They are mutually perpendicular to each other, but phase difference is 0 degree or 0 radian, right? Example, if let's suppose you have got a magnetic field like this, please see. This argument tells us that EM wave is traveling towards positive x-axis. Please note this thing, that by seeing magnetic field or electric field, you can get to know in which direction that field is going, in which direction EM wave is traveling. Even if I am going to only see electric field equations, I can tell how. By this omega t minus kx, omega t minus kx. That means EM wave is traveling towards positive x direction, not negative, positive x, right? Now this will tell you that electric field is oscillating in y direction and magnetic field is oscillating in z direction. So the third direction is x. Got it? And it is something like this. The direction is given by electric field cross magnetic field is equals to C cap. So this is for direction, my dear friends, and all direction everyone knows the trick, that is I cap cross j cap is equals to k cap, is equals to k cap. Use this trick, you can find out every answer. So you have got two things, one is direction of EM wave and the another one is magnitude of. So for magnitude, the formula is something like this, that is E naught divided by B naught is equals to C. So these are the two formulas from where you will get some questions. Do note it. Clear? Any more doubts? Be quick. Let me know. Sorted? Just now we have talked about energy density of magnetic field. Similarly, remember the energy density of electric field. These are 50% of total energy of EM wave. Then you have got average density, right? And because these are sinusoidal functions, so square of sinusoidal function, so it would become 1 upon 4. And then please remember that average energy density of electric field and magnetic fields are going to be same, just now I have told you. And then remember the total average energy of EM wave. total energy density, these formulas also. So how many formulas we have got over here? I think 1, 2. Please also remember this. We are going to talk about this in wave or in ray optics also. And the next formula is these. So around 5 or 6 formulas. By the way, these are not like different formulas. You already know this, right? You already know this. So these are simply the average formulas. Any more doubts? Be quick. Everything's clear? Done? And then you have got, next one is you have got intensity of wave. Intensity is known as power divided by area. Simply remember power divided by area, and then you can write down, instead of power you can write down energy divided by time. So energy was 1 upon half epsilon naught E square. You can use average formula for any two. Either you can write down 1 upon 2 epsilon naught E square, or you can write down B square divided by 2 mu naught, because average energy for electric field and magnetic field are same, right? So last formula for this one is displacement current, and that is epsilon naught d phi by dt. Again, this is important because in NEET 2025 they have asked a question from displacement current, right? Displacement current is that current which flows in a region when there is varying electric field. So it's going to be written as epsilon naught times d phi by dt, right? Clear? And this phi is electric flux, not magnetic flux, electric flux. That is, if you are going to write it down, id will become epsilon naught dEA by dt, and A is constant, so you are going to get epsilon naught A times dE by dt. So when electric field is changing with time. All right. So we'll keep it till here, because in next 10 to 15 minutes, ma'am will have her class, and after this we'll continue. Clear? So we have almost completed these things. Please remember, I have already made a video on modern physics. I have explained all the formulas from dual nature, atoms and nuclei. Right? So the video is uploaded on this channel only. You can check. In that I have explained all the shortcut formulas also. Clear? All right. So then we'll keep it till here, and after this let's meet in our next live session. Information about that live session you will get on the same channel. Please remember, for modern physics I have already made a video of all the formulas, and it is in this channel only. Okay then, see you guys, and as promised I'll get these PDF to you. After some time it will get uploaded in the description box. Okay, thank you so much. Bye bye. See you in the next live class. Okay, bye everyone. Bye.